Hi, welcome to the video. My name is Bharat Sunkwali. I'm a computational scientist at Bayer Pharmaceuticals. I'm located in New Jersey. I would like to start off by saying a big thank you for all the organizers for this incredible hackathon. I'd like to start off with the problem statement, and this is the GitHub repository for the hackathon. I work with clinical trial data on a day-to-day basis. I help key stakeholders to find insights by using statistical procedures and computational methods. One of the major pain points in clinical trials is the slow patient recruitment, and the reason for this is the lack of awareness about the clinical trials. I believe that we could bridge this gap between patient and clinical trials by providing a simplified search process to the clinical trials, and which is where we could leverage the Fabric and OpenAI capabilities. We need two data sources for the use case. The first one is coming from clinicaltrials.gov. We could just go there and download the CSV files, which will have all the clinical trials. And then we also have another publicly available file with all the zip codes for the geolocation. Now let's head to the notebook. So this is where all the magic happens. So the first step, so I basically have 4 steps, and the first step is installation, setting up the environment, and then we have the text embeddings and indexing. Unfortunately, I was not able to use the OpenAI text embedding because of technical issues, but this is so I have used the sentence transformer and FASS library for embeddings and indexing. And I'll just walk you through quickly, go through the steps here. So the first step is to convert the CSV file into a data frame, and once we have the data frame with within the data frame we have a row, and each row corresponds to one clinical trial, and we have several columns. The first step is to concatenate all of these columns into a string column, and then we convert that to a list. So once we have the data in this format, in the list format, we then create embeddings, and then once we have the embeddings, we then save them and also create the index. And then once we have our vector database ready, we'll move on to the next step, which is a similarity search. So we get 2 parameters from the user. One is the query, which is the diagnosis of the subject. In this case, it could be a lung cancer. And the second parameter is the zip code, because the patient would like to see the clinical trials that are happening within a certain distance from where he lives. So with these 2 parameters, we're going to do a similarity search and then bring down the clinical trials that are relevant for that subject. And once we get that information from the vector database, we're going to pass that information to LLMs, so which is where Azure OpenAI comes into play. And here I would like to show some responses that I have received. So the first one here, I can just quickly run and show you. So just the user can ask. So I will have to rerun the whole notebook. So for now, just for the interest of time, I'll just go with the responses that I've got in my previous run. So the patient can ask, okay, I understand that there are like a number of clinical trials near me, but I would like to know how long the trial lasts, right? So what's the treatment duration of each trial, and what's the primary outcome of each trial? So immediately, as soon as the prompt is given out, the patient will have, or the subject will have all the information he's seeking. Or he could have another question, right? So, okay, I have these studies. I would like to know what are the adverse events, what are the side effects for each of this study. Based on that, I can make a decision. And if there is no such information, just point me to a URL or a website where I can get more information. And that also works because all this information is already present in the data, and we're able to retrieve that information with the natural prompts. So these are a few questions that that the patient can ask that are very relevant for them. And if it would have been a clinical trials or text-based search, this would have been very difficult for them to go through all the documents and the links to get the information we're seeking. So I think that's what I have worked on for this hackathon. So it basically touch bases upon the RAG, upon the Azure OpenAI. But the end, I was able to leverage all the experiences that Fabric is offering, and able to come up with uh, with a natural language simplified search basis.